All right, hey, so here's the latest on this project I've been playing with. So, Z80 computer over here, interface board, which I've cleaned up despite this rainbow of wires over here. It's down to about a half dozen chips, and this basically monitors the I/O request, read write, and two address lines from the Z80 and feeds information from that to the Arduino and allows this Arduino, it's a little nano, to process I/O requests. So simplified BIOS over here, basically console status in out and disk read write. So when it wants to send a character to the console, right, this Arduino does a handshake with this based on what's happening on the I/O and memory bus. And figures out what character should be displayed. And when a character is requested from the console by the Z80, this will have buffered up, any characters that came in from the keyboard, and will simply supply those. For the floppy disk, right, I got a little SPI-based micro SD card reader and software that implements a whole FAT32 file system on here. So to make the floppy drive, I basically created a different directory for each drive. So I have 4 directories on this SD card. They're called A, B, C, D. Guess what? Those are the 4 floppy disks. And each directory has 77 files named 00 through 76. Those are the tracks. And each of those track files contains 128 times 26 bytes. That's the binary contents of the 26 sectors on the corresponding track. So when the Z80 wants to read, so it goes through the BDOS, right, to access something off the floppy, that gets turned into a BIOS set of BIOS calls that basically try to set the disk, the track, the sector, and the DMA address, and then a BIOS call that says read or write. And at that point, the BIOS basically does a handshake through a few output ports and input ports, so that the Arduino will basically know which part of which file and which directory to access, and will go down to the right spot in that and either ingest bytes from that or write incoming bytes to that. So it's a full floppy disk system working on. It's taking a tiny little piece of this 32 gig flash drive, but that's all good fun. The other thing I did was instead of hooking this thing up to a laptop to communicate with it, right, it's completely standalone now. So there's a PS2 cable coming in here, and I have a USB to PS2 converter, and just a plain old traditional keyboard hooked up to this, and this is all software that other people have written and made available. So there's a PS2 keyboard library for Arduino. And basically the 2 lines from the PS2 cable, so clock and data. Clock drives an interrupt, data gets sampled when the interrupt fires, and the code keeps track of the incoming pulses, translates them to scan codes, translates that to ASCII codes. On the output side, I have this cool little 20 by 4 LCD display, and this is an I2C device, and there's a liquid crystal I2C library that I'm using for this, and a little bit of basic code I put together to do some scrolling and things like that. And so this is a nice, kind of self-contained but really difficult to read CPM interface. Difficult because it's only 20 characters wide. So the other thing I did with this was once I had CPM up and running and I had my BIOS written, I wrote a little put program that basically reads the upper bytes of memory, so the upper few K where CPM is, and just writes it directly byte for byte onto track 0 of this floppy drive's disk A. And it only took about 75 tracks, I think, so I 75 sectors, so I fit it all in one track. And then I wrote a loader program. The loader program is really short, right? Too long to toggle inconveniently, but pretty easy, to write and load with the loader. And the bootstrap program basically just reads the first track of this floppy, copies the contents into the higher bytes of memory, and then does a jump to the starting location. And that bootloader is stored in one of the flash files on the Z80. So let's power up the Z80, and the file number I'm using is 20 hex, so this address bus is already set for 20 hex, and this is set for 10 hex, which means read just page 0. That's 4,000 bytes. We only need the first 100 bytes or so, but if I hold down the stop button and press deposit current, it will read in from the flash memory, load that in, and now I can go ahead and reset, and when I hit the run button, it will go ahead and start executing that bootloader. So I'm going to reset my Arduino, which will flash my display briefly. And as the bootloader runs, it will display on my display coded information showing me each track that's being loaded. And it's just, you know, random looking ASCII characters, but it's progress, right? So it lets me know that it's doing its thing. When it's done, it will print out an exclamation mark, and then it jumps to the code that it loaded, which is CPM, and guess what? There's our CPM prompt, right? A greater than. So we're off and running, and I can say, you know, directory, and there's my directory listing. Now, you know, it's scrolling, it's really fast, it's refreshing, and so on. So this is easy to read, you know, small amounts of information, but not terribly useful for you know, anything in practice. But you know, I've got a file called newfile.txt, and I can say let's type that, and there's the contents of new file. And you know, if I want, I can even like go in and say let's run mbasic, and it will take a little while. And there we go. We've got BASIC up and running. So that's pretty cool. And you know, 1981. So that's 40 years ago, right? In July, and it still runs on hardware in 2021. Pretty cool. All right. So let's make some LEDs flash, just as you know, something to do. So let's load StarTrek.basic. And this is cool because now, you know, we've just got lots of flashing lights going on over here. The way lights should flash on a front panel display. So that's kind of cool. The keyboard program I'm using does not recognize Control-C. I think I need to go in and actually trap the control key itself. But I tweaked it so that the escape key will function as a Control-C. When it detects the escape key, it'll send ASCII code 3. So I can say list, and I can start listing, you know, the code for Star Trek, and I can hit an escape, and that'll do a Control-C, and so on and so forth. So that's all good fun, right? And I can say files. I can see all the files I've got out there. Check it out. I've got a file called primes.basic. So I can load that. And I can list it, and you know, it's the standard prime number check, and if I run that, hip, there we go, we got prime numbers being generated, flashing, scrolling off the screen. It's fantastic, right? So there we go. Just kind of, you know, messing around with interfaces, old operating systems, and seeing what we can do, and mostly just making lights blink and having a good old time. So there we go. All right, thanks. Bye.